All right, this is page 320. Graphing the solutions of an inequality. A solution of an inequality that contains a variable is any value of the variable that makes the inequality true. For example, 7 is a solution of x is greater than -2, since 7 is greater than -2 is a true statement. So let's look at these examples on this page to help us understand that. Example 1. Graph the solutions of each inequality and check the solutions. So part A, we have y is less than or equal to -3. Because we know y can be -3, this part here is important. We're going to draw a solid circle at -3, and that shows that -3 could be a solution. So down here, they drew a solid circle at -3. Then y could be any number less than that, so we're going to color in any number less than that on our number line. That means any number that falls in that shaded section could be an answer for y. And we can prove that by picking a number. Look at step 3. Check your solution. Choose a number that is on the shaded section of the number line, such as -4. Substitute -4 for y. So over here, if we put -4 in for y, is -4 less than or equal to -3? It is. So we know that that is the right solution. All right, let's look at part B. Part B says 1 is less than m. Now in this case, m cannot be 1. It's not equal to 1. It's less than. So what we do is we draw an open circle on 1. Draw an empty circle at 1 to show that 1 is not a solution. In the last problem, we colored it in because -3 could be a solution, but in this instance, -1 cannot be one cannot be a solution, so we leave the open circle. But then we still shade everything because m has to be bigger than 1. So it's not 1, but it's anything bigger. And then again, step 3, to check our answer, we substitute any number that's in this shaded section to see if it works. They just happened to pick 2. We said, let's try it. Is 1 less than 2? It is, so that's a solution. Now we're down to the reflect at the bottom of the page, critique reasoning. Inez says that you can write 1 is less than m as m is greater than 1. Do you agree? Well, if you think back to number 14 from Mountain Math, where we had to graph two numbers and tell the distance between them, and then you had to write the statement, and I always said, write it both ways, then you already know that you can do what Inez says. This 1 is less than m is equal to that, and we can prove it by looking at B, what they did. Up on B, they said 1 is less than 2. If we switch that around, is 2 greater than 1? Yeah, this is the same thing. So a good answer for this would be yes. The two inequalities have the same solutions. Doesn't matter which order you put them in. Now number 2 says analyze relationships. How is x is less than 5 different from x is less than or equal to 5? Well, hopefully you're able to look and notice it's because of this inequality sign. In one case, x has to be less than 5. That means it can't be 5. And in the other case, x is less than or equal to 5. So it means 5 could be a solution. So a good answer for 2 would be for x is less than 5, 5 is not a solution and is not included on the graph. For x, and I'm going to have to draw this symbol in, for x is less than or equal to 5. I don't know if this is going to work. I hope it does. I might just have to go back. There we go. I'll just say for the other example, 5 is a solution and is included on the graph. Sorry, I can't make that little symbol on my computer, but both of them. So let's look at it again. For x is less than 5, 5 is not a solution and is not included on the graph. For the other example, 5 is a solution and is included on the graph. So in the first case, when we were graphing it, the 5 would have an open circle over it because it's not a solution. And the other example, 5 is less than or equal to, it would have a colored in circle because it would be included. All right, we are done with this page.